Hello, Algebra 2 students. This is Unit 3, Day 2, and we're talking about complex numbers for the first time today. Complex numbers have a real part and an imaginary part, and the imaginary part is called I. And I came up because we needed to know the square root of negative numbers. And if you think about it, the square root of negative 1, it can't be positive 1 because 1 times 1 is 1. And it can't be negative 1 because negative 1 times negative 1 is also positive 1. So mathematicians invented this new number, which is I. I don't know why these are on two different lines, but I is equal to the square root of negative 1. And you can use I to write down the square root of any negative number. Now, because I is the square root of negative 1, if you squared I and you squared the square root of negative 1, you would get I squared. And on this side, you would get negative 1. So I squared equals negative 1. So if you have a negative number, like the square root of negative 5 over here, you can change the square root of negative 5 to be the square root of negative 1 times the square root of 5. The square root of negative 1 is I, and the square root of 5 is still the square root of 5. So we're going to do a few more examples, finding the square root of negative numbers. The first one here is the square root of negative 120, so I'm going to first make that the square root of negative 1 times the square root of 120. So that's going to become an I. Now the square root of 120 is something we can simplify, so we're going to break that down into its prime factors. I'm going to go 4 times 30. 4 is 2 times 2. 30 is 6 times 5. And 6 is 2 times 3. So anything that shows up twice is something that we can take out. So we can take this 2 out. And then I have a 2, a 3, and a 5. So I think the rest of this is stuck underneath. So this is going to become I times 2, so I'm going to put the 2 in front, 2I, and then square root, and what's left under the radical is 2 times 3 times 5, which is 30. So your final answer is 2I root 30. Okay, square root of negative 96. First step is to write square root of negative 1 times square root of 96. Square root of negative 1 is I, so I have I root 96, and now I want to break 96 into its prime factors. So I know I could do 2 times 48, and 48 is 2 times 24. For 24, I'm going to do 4 times 6, and 4 is 2 times 2, and 6 is 2 times 3. So anything that shows up twice can come out. So these 2's, that can come out as a 2, and these 2's, that can come out as a 2 also. So I have I outside. I also have a 2 and another 2. So I have 2 times I. And then what's left underneath is 2 times 3. So I have 2 times 3. I have 6 underneath my radical. And then just get these all together to be 4I root 6. Okay, we also need to talk about powers of I. So we know that I is defined to be the square root of negative 1. And if we square the I, that gets rid of your square root, so you have just negative 1. If you have I to the third, you can break that into I to the 1 times I to the 2. I to the 1 is I, and we already know I to the second is negative 1, so that gives us negative I. And I to the fourth can be I squared times I squared. Each of these I squareds is a negative 1, so negative 1 times negative 1 is positive 1. Now your calculator can be helpful with these first 4 powers of I so that you don't have to always remember all of these steps. But for higher powers of I, for some reason your calculator is not so helpful. Let's see how that looks. On your calculator, you want to go to Mode, and you've been in real mode all this time, but you need to change it to A plus BI mode. So go down to A plus BI mode, and then press enter on that. And then we can do second quit, and we need to be able to see the I. The I is above the decimal down here, so I'm going to do I squared. So second I and to the second power. So it tells you I squared is -1, and you can do I to the third, second I raised to the third, and you can do I to the fourth. And the only values for I to a power are I, -1, -I, and 1. Those are the only possible answers you could get. But if you get to a higher power of I, and I'm not sure if this one's going to be a problem or not, but let's try I to the fifth. Sometimes it's going to give you an answer, but sometimes, say I wanted to do I to the 50th, sometimes your calculator is just not helpful. In this case, this calculator is newer, so it's giving me answers for everything here, but you sometimes get something that just looks very messy, and so you need to know how to do this also without a calculator. So let's look for other methods. So if I had I to the 14th and my calculator was not being helpful, what I can do is this. I can figure out how many times I go through this cycle. So I know that I to the 4th is 1, and then this would be I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9, I to the 10, I to the 11, I to the 12. So every time I go through this, I get back to 1. I to the 13, I to the 14, so my answer should be -1. One way you can do this is you can divide 14 by 4. So 14 divided by 4. Oops. Okay, so I get 3.5. So if you can remember that if you divide by 4 and you get no remainder, your answer is going to be 1. If you get something 0.25, your answer is going to be I. If you get 0.5, your answer is -1. And if you get 0.75, your answer is -I. So because I have a 0.5 here, my answer should be -1. For I to the 23, if you do 23 divided by 4, you should get 5.75. And because that's a 0.75, you're going to have a final answer of -I. Now it is possible you could count through this all the way to 23 if you really wanted to, if you're not making any sense of the 0.75 part. So you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 23 to see which one you land on. These numbers get so big that that can be difficult. 45 divided by 4 is 11.25, so that would be just I. 68 divided by 4 is going to be, let's see, 17. So there's no remainder, so that's going to be 1. And 124 divided by 4 is 31. There's no remainder, and so that's also going to be 1. All right, let's turn the page. Okay, in this part, we're talking about the real part and the imaginary part of complex numbers. So 2 plus 3i, this expression has two terms, but it's really just one number. So if you want to add or subtract real numbers, you just add the real part to the real part, and then let's change colors, the imaginary part to the imaginary part. So it's just like adding and subtracting like terms. It's not any different. It's very possible to do this without a calculator, but if you are so inclined, your calculator will do the work for you also. So I'm going to add the 4 plus the 3. Let's go back to purple. 4 plus 3 is 7. And negative 1i plus 2i is positive 1i. So I have plus 1i. Or you could have just plus I. Now you can check that on the calculator. So you can also do these problems on the calculator once you're in a plus bi mode. So always check your mode before you start doing this. I have 4 minus I and plus 3 plus 2i. And I got 7 plus I, just like I did here. Okay, when you subtract, remember to distribute the minus to each term. So I have 7 minus 5i minus 1, and then minus minus makes this plus 5i. So my negative 5i, my positive 5i cancel out, and it's just 7 minus 1, which is 6. All right, and this one is just a longer problem, but the same idea. Distribute the minus to each of these. So it's 6 plus 2 minus 9i. Bring this down, plus negative 8 plus 4i. Now you can put the original in the calculator, that will work, but you can also combine like terms. So 6 plus 2 plus negative 8, that actually all cancels out. And then negative 9i plus 4i, that's negative 5i. For multiplying, you can also do these on the calculator. What I'm going to do first is show you how to do it without the calculator. So distribute the 5i to each of these. So I would have negative 10i plus 5i squared. Now when you get an I squared, you want to replace that with a negative 1. So it'd be negative 10i plus 5 times negative 1. And that gives you negative 5, so your final answer is negative 5 minus 10i. For these other problems, you can FOIL 7 times negative 1, 7 times 2i, negative 4 times negative 1, negative 4 times 2i. But you can also type on the calculator. So let's try that one. 7 minus 4, and second I, close parentheses, times negative 1 plus 2i. Okay, so I get 1 plus 18i. Okay, and the next one you're going to type in your calculator as well, and because this pattern is the same as the pattern of difference of squares, you're going to get something interesting here. Your middle terms cancel out. So you can type this in the calculator to check, but what's going to happen is I get 6 times 6 is 36. And I have a negative 18i and a positive 18i, which cancel out. So 18i and negative 18i, those cancel. And then I have 3i times negative 3i, which is negative 9i squared. I squared, remember, is negative 1. So if I have negative 9 times negative 1, that makes a plus 9. So I have 36 plus 9 equals 45 for your final answer. Okay. Down here, this section's talking about complex conjugates, and we're going to save that part for another day. And let's skip to the next page. So you use the conjugates for problems like this with complex numbers, but we're going to go on to example 8, solving quadratic equations, and these equations are going to have answers that are complex or imaginary. So you need to get the x squared by itself, so I'm going to subtract the 10. And you have 3x squared equals negative 36. Divide by 3. X squared equals negative 12. Now remember that when you solve this with a square root, you need a plus or minus. So plus or minus square root of negative 12. So the negative part comes out as an I, and you want to break the 12 into its prime factors. So x is going to equal plus or minus I root 12. And let's break the 12 down. We have 3 times 4, and the 4 is 2 times 2, so the 2 is going to come out. So it's going to be plus or minus 2i. and we still have a 3 underneath the square root. All right, next one. We have to get our x squareds together, so I'm going to subtract x squared from both sides. I have negative 7 equals 3 x squared plus 5. To get the x squared by itself, you need to subtract the 5. Negative 12 equals 3x squared, and divide by 3. So I have x squared equals negative 4. I'm going to solve this by doing a plus or minus square root. So I get x equals plus or minus. Now the negative comes out as an I, and the square root of 4 is 2, so it's just plus or minus 2i. Okay. Problems down here, these are problems that we're going to solve with a quadratic formula, so I'm going to save those for another day. And we're going to skip ahead to problem E. In problem E, you have a square, so we're going to solve with a square root again. It's a little bit different, though, because you have a binomial in the square. So we're going to isolate this square by subtracting the 8. And I get negative 4 equals 2 times x plus 3 squared, and divide by 2. So x plus 3 squared equals negative 2. And now I'm going to do a plus or minus square root to get rid of my square. So there's my square root and my plus or minus square root. So x plus 3 equals plus or minus. The negative comes out as an I. Negative I plus or minus I root 2. And to get the x by itself, you need to add a negative 3 to both sides. So you get x equals negative 3 plus or minus I root 2. Okay, in example F, we're going to do the same thing. To get this x plus 1 squared by itself, I have to add 2. So I have 5 times x plus 1 squared equals negative 4. Divide by 5, which gives me negative 4/5. And then we're going to do a plus or minus square root. So square root plus or minus square root. So x plus 1 equals plus or minus the square root of negative 4/5. Well, the negative is going to come out as an I, and the square root of 4 is 2, but the square root of 5 is the square root of 5. That's kind of a pain. Let's see if we can make some more room here. Okay, so x plus 1 equals plus or minus, and let's see, let's make this negative 1 times 4, that's the negative 4, over the square root of 5. That's the I, and that's 2, so it's 2i over root 5. Now, you may never have done this before, but you're actually not supposed to have a square root in the denominator. So if you ever see a square root in the denominator, you can do this step called rationalize, which means that you multiply both the numerator and denominator by the same square root. You're allowed to do that because root 5 over root 5 is really just the number 1, and multiplying by 1 doesn't change anything. But what it does do is it gets the square root out of your denominator, because root 5 times root 5 is the square root of 25. The square root of 25 is 5. So I have plus or minus 2i. I have a root 5 up top, but on the bottom, the square root of 25 is 5, so that's going to be a 5. I still have x plus 1, so now I can finally move my 1 over there by subtracting 1 from both sides. And then I have x equals negative 1, plus or minus 2i root 5 over 5. Okay, and that's it. After this, you're going to try your practice problems.